Welcome. In this video, I am going to discuss all about the Fourier series of bipolar rectangular wave. I am going to show its derived solution of exponential form, combined trigonometric form, and trigonometric form to get its result, which is the rectangular waveform. Furthermore, I will be discussing the computation of the VRMS, the waveform of different transformation of signals, the simulated circuit, and the actual simulated of the circuit. Using the rectangular waveform shown in the figure, we will first represent this into a mathematical expression. We can write it mathematically as x sub 1 of t is equal to v of 0 less than t and dt over 2 greater than t, minus v of dt over 2 less than t, and t times 1 minus d over 2 is greater than t, and v of t times 1 minus d over 2 less than t, and t greater than t. So for us to get the exponential form, we'll first find the c sub k, or the coefficient. So c sub k is equals to 1 over t times the integral of 0 to t x times t times e raised to negative jkw sub naught times t dt. Upon substituting the value of x, we arrive at c sub k is equals to 1 over t times the integration of 0 to dt over 2 times v times e raised to negative jkw naught times t dt minus the integration of dt over 2t times 1 minus d over 2 v times e raised to negative jkw naught times t dt plus the integration of t times 1 minus d over 2 to t v times e raised to negative jkw naught times t dt. So we will first substitute the value of the w naught. W naught is equals to 2 pi over t. So upon substituting, c sub k is equals to v over negative jk times 2 pi over t times t, and so on. And upon the integration and computing the coefficient, or the c sub k, we arrive at the answer of c sub k is equals to 2 times vd times sine k pi d over k pi d. Next is the computation of the c naught is equals to 1 over 2 times t times the integration of 0 to t times t dt. So upon substituting the value of x of t, c naught is now 1 over 2 times t times the integration of 0 to dt over 2v dt minus the integration of dt over 2 to t times 1 minus d over 2v dt plus the integration of t times 1 minus d over 2 to t v dt. So upon integration, c naught is equals to v over 2t times dt over 2 minus 0 minus t times 1 minus d over 2 minus dt over 2 plus t minus t times 1 minus d over 2. C naught is equals to v over 2 times t times dt over 2 minus t plus dt over 2 plus dt over 2 plus t minus t plus dt over 2. And now c naught is equals to v over 2t times 4 dt over 2 minus t. And upon computing, the result now is the c naught is equals to v over 2 times d minus 1. So for the computation of the VRMS, the formula of VRMS is equals to the square root of 1 over t times the integration of 0 to t x times t raised to 2 dt. So upon substituting the formula of x of t, VRNS is now equal to the square root of 1 over t times integration of 0 to dt over 2 v dt minus the integration of dt over 2 to t times 1 minus d over 2 v dt plus the integration of t times 1 minus d over 2 to t v dt squared. VRMS is equals to the square root of b squared over t times dt over 2 minus 0 squared minus t times 1 minus d over 2 minus dt over 2 squared plus t minus t times 1 minus d over 2 squared. So upon simplifying and computing the VRMS, we arrive at the answer of VRMS is equal to 0.592. So for the form of the bipolar rectangular wave, or the Fourier series of the bipolar rectangular wave, we will use the frequency of 1, t of 1 over f. B is equals to 1, w is equal to 2 pi over t, and distance is equal to 0.5. The j is equals to the square root of -1, and the time is 0.0.001. So for the exponential form, we will use the formula for exponential form, and we will substitute the coefficients, and it arrives like this, and the waveform of the exponential form, or the results of the derivation of the coefficient. And upon substituting the exponential form of the rectangular wave is now like this. So we'll first compute the trigonometric Fourier series. So the given is c sub k is equals to a sub k plus I times b sub k over 2. So c sub k, a sub k, b sub k is the coefficients of the Fourier series. A sub k is equals to 2 times c sub k. So since rectangular wave is an even function, b sub n or b sub k is equal to 0. So for the c sub k, we have 2v times d sine c sub k pi d. So since a sub k is equal to 2 times c sub k, we'll substitute the value of the c sub k. So now the a sub k is equal to 4b times d sine k pi d. And we have the result for the c naught, which is c naught is equals to b over 2 times 2d minus 1. Since c naught is equals to a naught, so a naught is equals to b over 2 times 2d minus 1. So this is the formula for the trigonometric Fourier series. X of t equals to a naught plus a sub k times cosine k omega w sub naught times t. So upon substituting, we have now the trigonometric form, and it is just like the same as the exponential form. And for the combined trigonometric Fourier series, c sub k is equal to 2v times the sine c sub k pi d. So c naught is equal to a naught. A naught is equal to b over 2 times 2d minus 1. So theta k is equal to negative arctan b sub k over a sub k. Theta k is equal to negative arctan. So since it is rectangular, so b sub k is equals to 0. So now theta k is equals to 0. So upon substituting the given, we arrive at this kind of waveform in combined trigonometrical form, and it's just like the exponential form and trigonometric form. So for the VRMS, VRMS is equal to the square root of t times v squared minus 1 plus t over square root of 2 is equal to 0.5. So here is the transformation of the signal. It is the transformation signal of the time reversal, time scaling, time shifting, amplitude reversal, amplitude scaling, and amplitude shifting. So this shows the simulation of the bipolar rectangular wave. As the result of the oscilloscope, it is now a rectangular waveform using this circuit. I use this circuit for the actual simulation of the bipolar rectangular waveform. Shown is the actual simulation of the bipolar rectangular waveform and its results in actual. And that was the bipolar rectangular waveform. Thank you.